Yesterday we learned and reviewed how to factor when you had a binomial and you factored it possibly using the difference of perfect squares. Today we are going to talk about and review how to factor trinomials, and we're going to spend today and tomorrow talking about this. Okay, so I'm going to scoot it up and let's talk about how to factor when it's a trinomial. And it's one of the problems where the leading coefficient, or the number that's in front when it's in standard form, is 1. Okay, so these are the ones that are a little bit easier to factor just because you don't have to do as much. All right, and I went ahead and wrote the steps down so that we would have them to review with. All right, so the first thing you're going to look for is it a trinomial? In other words, does it have 3 terms in the expression? So if it does, then you're going to see if it will factor the way that we talked about factoring those types of trinomials. And so the way that we talked about these is you're going to use what's called trial and error. Okay, and so that part will come in just a little bit. All right, so just like every other factoring problem, you're going to see, does it have a greatest common factor? Does it have anything in common? Or do all of the terms have anything in common? And so notice in this first problem, they don't. And then it has 3 terms, so we're going to look to see if we can factor it this way. So go ahead and put your 2 parentheses. And then the next thing that's probably going to be helpful for you to do is, with these problems, you could go ahead and look at what multiplies to give you the first term. And that's actually what you're going to put in the first spot. So now this is very specific to these problems, because if it was one of the problems that has a number other than 1 in the front, then you're going to want to do it a different way. Okay, but this one's an easier one, so you're going to ask yourself, what times what gives me x squared? And so x times x gives me that. So that's actually what you put in the first spot. So we're going to go ahead and put an x and an x. Then you're going to figure out what the signs are. So remember, when you're trying to figure out the signs, you start by looking at the last sign in your expression. And so if the last sign is a positive sign, that means that the signs that go inside your parentheses will be the same. They'll either be both positive or both negative, and it's going to actually depend on the middle sign. So like if this was a positive, you would look at the middle sign, and if it was positive, you'd put both positives, or if the middle sign was a negative, you'd end up putting both negatives. Okay, so now that's if your last sign is positive. Now, if your last sign is negative, that just simply means that the signs in your factors will be different. So there's going to be a plus in one and a minus in the other one. Okay, and so notice when we look at this one, the last sign is negative. So that means that these are going to have different signs. And this is a problem where you can go ahead and put the signs in. If it's a harder problem, then you won't be able to put them in yet. Okay, and so from there, we're going to move to the next step. You have to list the factors of the last term. All right, so what multiplies to give you 6? Well, 6 times 1, 3 times 2, and then I think that's it. And now if you have trouble figuring out what the factors are, you can just simply, or what multiplies, I guess, to give you 6, you can start dividing that number by all the numbers you can think, and then that should very, very easily give you those factors. Okay, and so from there, this is where the trial and error part comes from. Okay, you're going to look at those numbers and you're going to ask yourself, what numbers multiply to give you the last term? And then, but out of those numbers, they have to actually combine with whatever signs you have to give you the middle term. And so when I'm looking at these, I'm going to say to myself, okay, which of these numbers will combine with different signs to give me this number in the middle? So that number in the middle is technically a positive 1. So like if I take a positive 6 minus 1, that's not going to do it. If I flip-flop that and take like negative 6 plus 1, that's not going to give me 1 either. But if I look at these, if I take a positive 3 minus 2, Positive 3 minus 2 gives me positive 1. So that those are the numbers that would work to give me my answer. Okay, so, and again, you can multiply this out to check to see if it works. So if I multiplied this out, I actually should end up getting that in the end. All right, so let's do another one. All right, first thing, it's a trinomial. It has a 1 in front, so I'm going to do it this way. I'm going to ask myself, okay, does it have a GCF? Do they have anything in common? And no, they don't, so I can go ahead and put my 2 parentheses. What times what gives me x squared? X times x gives me x squared. Look at the last sign. It's a positive. So that means they're both going to be the same. So to figure out what they're both going to be, I look at the middle sign. So that means that they're both going to be negative. So you can go ahead and put them in there. And then you're going to go to the side and you're going to start listing out what multiplies to give you this term. So 24 times 1 will give me that. 8 times 3. 6 times 4, 12 times 2. And then if there's more, you could keep listing them. But a lot of times I'll list some and I'll see if any of them work. So keep in mind that the signs are going to be the same this time. So it's almost like you're going to be kind of adding them in a way. So like which of these, when I combine them, will combine to give me a negative 4 in the end, okay? And so if I take 24 or negative 24 minus 1, that's not going to work. If I take negative 8 minus 3, that won't work. Negative 6 minus 4, negative 12 minus 2, oh no, none of those work. Well, are there any other factors of 24 that I could try to work here? And I'm not thinking of any more. So that means that this may not be factorable, okay? And so if it's not able to be factored, like none of those factors will combine with the signs that they have to give you that middle term, then that actually means that this is a prime expression, okay? So if it cannot be factored, you put prime, all right? All right, let's do 2 more so you can see at least a couple more ways that they work. All right, so same thing. Trinomial, 1 in front. I'm going to put my 2 parentheses. What times what gives me x squared? Well, x times x. My signs, they're going to be the same. They're both going to be positive, which means they're going to add together. And then I'm going to start listing out my factors of 36. So we've got 36 and 1. 18 and 2. Let's see. 12 and 3. 4 and 9. And then we could keep going to see if there's more, but let's see if any of these will work to give me what I want. And if not, we'll keep going. Let's see. So they've got to have the same sign. So 36 plus 1, 18 plus 2, 12 plus 3. None of them are giving me 12 yet. 4 plus 9. Nope. So we got to keep going. 6 and 6. That may be it. Because if we take a positive 6 plus 6, we get 12. So that's what goes there. So like I said, you just kind of start figuring out all the things that multiply to give you the last one. And then they have to combine with these signs to give you the middle one. All right. So then the last one that we'll do together is this one. It's a trinomial. It does not have a 1 in front. But if you notice, they do have something going on here. This one actually has a GCF. So if it has a greatest common factor, then you have to factor that out first. So they all have a 5 in common. So I'm going to take it and I'm going to divide each one of these by 5. So if I take this divided by 5, I end up with just the n squared. That divided by 5, I end up with positive 2n. And then that divided by 5 gives me a positive 4. Okay. And now, just like what I did with the other ones, I'm going to see if this factors. So if I take 5 and then we've got n squared plus, oh, I don't know what I'm doing. You put 2 parentheses, and then what times what gives me n squared? Well, it'd be n and n. I think I'm looking ahead here. And then my signs, that means they're both going to be the same. They're both going to be positive. Okay. And then I'm going to list the multiples of 4. So we got 4 and 1, 2 and 2, and then that's pretty much it. So which of these will combine to give you the positive 2? Well, it doesn't look like either one of these will. So that doesn't mean that it's prom. It just means it won't factor any more than where it was. And so the most we could go here is that step right there. So we actually will just erase what we were trying to do. And this would be as far as that would go. Okay. So you got a couple examples of where it would factor and then where it wouldn't factor as much. All right.